Hello, welcome to another video on Odin's. This is a video series where I'm working through an interpreter for the Z machine, which is something that runs text adventures. And I'm doing it all in Odin, which was a new language to me, but I've been doing it for a couple of months now. So I might just take a drink of water. I'm thirsty. Should have done it before I started. Anyhow, a couple of videos ago, I was working on the save, um, restore functionality, and I think I want to do the save now. I had also been uh, kind of showing off the check checker, um, which that's also another thing I kind of might visit if I have time, which is the version for property tables, which are slightly different. Can't do quite the same tricks. But for now, I'm going to do the save. So, save is following the Quetzal format, um, which we did for load, or restore, I think it is, not load. Load's loading memory, which is just above here. Reasonably beefy thing, to be honest. So there's a couple of helper functions that we uh, need to get. So this can be Kitsu biopath, I guess. And just that same thing that I did. So this is going to be a machine, and it's going to return a string, and it's going to have that stuff in, and we're going to return the file. What else can I kind of pull out? Not super heaps from here. So yeah, not super heaps. But we can get the file equal Quetzal. Get that file. And so once we get the file, we probably want to have like another check. Potentially I might add that in here, which uh, and this is going to be a bool, but it's going to be equal to true. And yeah, so I think this needs to equal to right. Nah, that's just cursed code. So if writable, we're gonna do one thing. Else. Why I say it's cursed code is because if we're wanting to also this should be false. So if we're wanting to write something, we probably want to check whether it exists and overwrite. Whereas in the read case, if it doesn't exist, then we want to have an error. Well, we really want to choose another file, something like that. And what I could have done, which would have been cursed as, is do something like if writable equals um, do something like that, and that would have just caught both of these cases. But I don't know. I'll do it this way. Um, cool. So down the bottom, so we are writing this file, so it will tell us if we're overriding. So I guess for now I'll probably just remove the file manually, because I want to overhaul the input system, and once I do that, it will be significantly easier to ask the user a question like, "What file do you want to save as?" So currently, it's just getting like the kind of a default based on the ROM file path. Cool. I pushed tab before I did that. Maybe even two tabs. So what we need to do here is we actually want to what do we want to do? It's like that. I'm like not in the right thing. So we actually want to just the fuzzy search in this is like sometimes not the best. So probably just want to get OS open, which that will mean we have a like file handle and an error, and this is going to be opening file. And do we need to say, yeah, we need to say the mode is O. Um, well, what mode can we have? Oh, I guess we want the one that we just overwrite, which I guess is truncate maybe. Um, these docs are like not the best because they're like kind of they're kind of just the same as the C standard library as into and so what do we have here? Cool. Flags can just have, yeah, we just want read write. Or write only. Do we actually have, yeah, we have a write only. Do we want a write only or, um, like maybe it'll be slightly more efficient. I don't, we don't need to read it. So I think it's if air not equal to nil, uh, to return false. And here we probably want to do a defer OS doc. close on that file handle. Haven't done a defer in a while. Cool. So here we have a file handle and we are wanting to write stuff to it. So we can just write and the we're just going to kind of write data as we get it, I guess. So we're going to have to first write. No, it's. I was watching videos in different languages today. Um, yeah, I might actually call it FD. Cool. So what are we going to write? We can write like an array of data bytes. So can we do something like this? We had like a transmute. Yeah, so we could do a transmute there. So like maybe detool that and do it again a couple of times. So we want to start with what was it that we wanted to start with? Form, wasn't it? Well, like we do kind of need to. No, do we need to? We don't really need to. We don't really need to. So where is it? Eight is kind of saying what it is. So everything has an ID and then a length. We don't know the length at the moment, but we know where we can seek back to. So I am wondering whether to, instead of doing it as we go, I actually kind of build a abstract form to do it, but it's also a good learning exercise to just write as is. So I think Indian, pardon me, Indian might have had what I want. What else was there in encoding? Nah, but can we? Yeah, we can like put. What do we want? We kind of want to put U32. Oh no, we can do the byte order in that. That's how we do that. Um, so here we want to do a. It's like 4 byte length. So we want to Indian dot put. Um, what do we have? That didn't do what I wanted. Oh, yeah, that did not do what I wanted. Let's just get here. No, just here. So put 32. So we give it like a byte. Uh, so this is just going to be like it's really just going to be that, but we can pass it a form data. We can just pass it the slice. And what else do we want to pass to this? We'll just pass that for now. And I think I want to do a defer here, in like a nice little block. So we can do like a seek back in OS. So seek we can do a offset and a points, which we will do a points. So I think we just want to do like jump over those 4 bytes for now, but we'll do a defer to write the 4 bytes afterwards. Now the points that we want to do one of these ones, seek current, seek in, and seek set. And we just want to do seek current. So we want to jump 4 bytes from where we are. So we can do something like that. And I think I might need to do something like that actually. And probably in here as well. Do something like that. So here we probably want to do this, and we probably want this seek to be seek set. So this is going to be 4 bytes after the form. So maybe just do just after form. And here we will write whatever we have as the form length, which will put in the correct form length. Yeah, I think that's a nice way to do it. Right, so what do we have inside of the form? We had to have a IF header to start with. First off, we had to write the type of yeah, so we actually had to write the type of what this form is, which is IF set that, and see that with that. So that is the form. So once we're inside the form, we need to write the IF header. So this is also going to have a IF header. Might just call it. We can just have that there. Uh, so I think here I want to do a because every time we do a write, we want to form length plus equal 4. So I think I actually want to do a capital form right, and what we're going to do is pass it fd, which I think was an os dot handle, and we're also going to pass it the data, which is going to be the byte slice, and we are also going to pass it the length, which is going to be a pointer to a int, I guess. It can be. I mean, I could give it a uint. And this is I think I got some mail. So this I will actually do Ketzel uh, form right and do that same thing, but then pass it the form length and an address too. So that should add to the form length. We need it to be on this side, and this needs to just be data. Um, it's interesting because I want. Hmm. Because at this point here, where we start writing I F header, yeah, something like this. We're adding to form length. Well, we're doing something like this to start with. And we're doing another defer. But here we don't actually know where to defer to. Well, I guess we can do like that would be after the length. That would be after the subtype, the IFZS. That would be after the IFHD. Um, and here we want to write, what do we want to write? IFHD length. And here we want to actually not do it like this. We want to do that and probably that. It's kind of annoying because like it would be good to kind of pass in the exact moment, exact place that you are meant to be. Um, but that is all right. So I guess I can do like a form start, and this can be os.tell. Do we have a tell? Do we have a tell? Uh, how do we know where we are in the file? Is it stat that tells us? Um, I, I'm pretty sure it's tell. Or if tell. Reposition a string. Oh no, that yeah. If tell is obtains the current position, whereas uh, stat only gives information about the file, which doesn't really include the where you are in the file pointer. Yeah, so that's kind of interesting. Like, how can you tell where you are? We do have the libc ftell, which I guess just takes a file pointer, which is not the same as a file handler handle. Eh, right. Anyhow, in our if header, what do we want to put in it? If header was down here, so we want to put the chunk length, which we don't know, but we've just put a thing there for. Well, actually, the chunk length is always 13. Which 13 is always uh, can we just do something like 0 0 0 13? Hey, where have I gone? No. Do something like that. Don't do the seek, because we just know this is going to be 13. I just want to see how much this compiles. So how do we tell if that open has failed? It gives an error, but the error how do we handle the error? Error equals os dot none. Not equal to os dot error none, was it? So this needs to be a put u32, and we also need to do dot big, because this is big, and that's how we know that that's the right thing. We don't have a big. What do we have in Indian? Indian. We just got put U32. Right, so this value comes after that. Do something like that. Cool. I actually want to do this make sure I haven't broken anything. Oh, I died. We'll just go back where we were. Cool. So that kind of works. And it didn't complain there. So what comes after the IHD? We have everything that came in this one here. So we have the release number. So I think I might want to do like a maybe I could try out that uh, function where we actually have something like this and something like this. And we then kind of overload it by doing what was it? It's just something like this. And um, I think it's just something like that. It's complaining about this, that's fine. This data we probably want to we make that U32. Um, this should be len data. That could have been an unfortunate bug. Here we probably want to call that value actually, and here we can value, and we probably need to make a data, and this can be a for U8. And this can be just FD and data and link like that, and then we don't really need to worry about that. And that way we can just kind of do the right thing. Yeah, we can do stuff like this and have the same functionality. So if I do this, it does not like this because a link may not be a U32. That's all right. We can pass it a slice. That's all right. And yeah, so it doesn't like this. So here I think I want to do this and like What do they call it? Procedure. Implicit comp. No. That's too far down, I think. Yeah, procedures, explicit overloading. Right, so we just shove a proc before that. And that just does the same thing. So that way we can call a function with the one name and it will just dispatch to whichever one it needs to at the time. And I think they'll make things like this a lot easier because now we want to write a just a word which is a release number. Um, so this is going to be header dot release, and here it will probably complain. I hope it will complain. Yeah, so it doesn't have anything that will release is a thing. We don't have a header. That is why it is an unknown type. Machine header from the machine. Not that one. This one. Right, it still doesn't like it because it doesn't have anything for U16BE. So what we can do is do maybe just this, and we can do the cast. Do something like that, and here we probably want to start breaking this out. And we can probably do like a string as well. We don't do that. Do that. Don't do that. Find the T. Do something like that. Do that again. Um, yeah, these have to be done manually. Yeah, so here we can use 16, and because we're not transmuting, we're casting, that should do the trick. Except in here we do it, cool, but we also don't do a string string and value. Give that a string, and here we want to do something like that. Um, transmute U8 with that bracket and just pass it the value. Yeah. Cool. Doesn't like that. Untyped integer. That's alright. We'll make it a U32 because we know that we want that to be U32. Cool. That's looking good. So what's next? 6 bytes of the serial number. So I think we can probably uh header.serial. It doesn't like that. But we can take a slice of it. Yeah, I reckon a slice would work. Checksum was going there, and the program counters. So that is not quite what we know. So we want to write PC is 3 bytes. And then we also want to just write a single byte of 0, which we should be able to do with just like a U8. Um, so this is going to go in the middle. What have we done? Cool, it doesn't like this because it's an invalid type. Is that because it is? Yeah, so we need to say it is a U8. Cool, and that's working. So the PC we need to get by kind of just doing the inverse of the restore. Just because of the way we pass the instruction. So this is an unsuccessful save, which means I guess it means that the file couldn't be opened. Do we need to like create this thing? Oh yes, please. Um, come on. Something like that. We do the trick. And I think just because I'm not breaking too much. I'll just kind of have a basic save that one. Gosh. Right, so it should hit straight away. So the PC, if we get the we have the machine and we have frames, so we should have um be able to get the current frame by getting then machine dot frames minus one. So that should get the current frame. We should probably do then machine dot frames equal to 0, do return false. And maybe we could do this up the top and then maybe make a current frame equal to machine dot frames of the len machine dot frames minus 1. Maybe not right up the top, maybe like maybe just there. So in that current frame, we will have a what am I thinking? We'll have the PC. So that current frame has a PC. Now the PC that we want, we actually want to do something like the inverse of this. Um, which kind of means it's a U32. But it's going to be a U32. Well, that is kind of what the U32 is there. So what are we thinking here? So yeah, we'll need to get the machine. My eyes are becoming fuzzy. The meds I'm on, don't know. It's been good for quite a while, but I don't know. Recently, it's well, recently, as in the last couple of days, we're not doing a branch. We're not doing a so I think that is that. And so here I kind of want to do PC data. And this can be a so like this Indian library. I wonder if we do a put EU32, this slice, does it have to be 4 bytes? Yes, it does. Um, so that kind of means that we need this to be a 4 byte 4 byte thing, just so we can go in dot put u32, and we're going to do PC data there, and we're going to do dot big, and we're also going to pass in the PC. But now we're only going to write and we're only going to write PC data one onwards. So we're going to skip the first byte in the big Indian. So it, yeah, I believe that should do the trick. And then we write the 0 byte at the end. And I feel like I might need some specifications. We can't link exactly to this, but we can link to, gosh, we can link to that there. So this, we can probably do that. And I feel like this whole thing can probably go out into its own kit. So, right, I header, and we can just give it the FD. And maybe the take this and kit to right I header, no, it's IFHD, and we're going to pass it the machine, and we're going to also pass it the FD, I guess. And we're also going to pass it the address to the form length. And then here we can have kit. So right, that is going to be a proc, and it's going to take the machine. It's also going to take a stop handle. I think that's right, and it's also going to take a length, which is going to be an address to U32, and this is we're going to have that. And so then and just those. Cool. So what do we have to write after the IFHD? We just have to write that before we write the memory or the stacks. How long have we done? We've done an hour on just writing the header of the save. I thought this would be quicker. I thought I would also be able to get the property tables done as well. But that is all right. So what do we have for the stack? We can work out the trunk length ahead of time because we can work out yeah, we can work out all of this. Oh, can we? Because like it's got like a variable number of variables and um we can go through them all. Um and it's just got a bit of overhead there. And for the CMEM, we need to work out the compressed data, which we don't actually know. But the thing is, once we write the um, so like we can do like CMEM and um, sticks, was it? I think it was sticks. Sticks. So once we do all those, that should get all that defer stuff. Do that same thing and do that same thing. Um, this is just going to be unimplemented. Yeah, and this is also going to be unimplemented. So, kind of what I'm thinking is we can have a sticks length. Gosh, there was a tummy groan. And this can be a U32. And we can do all this Quetzal form right type stuff. But instead of doing it on the actual length, we can do it on the sticks length. Um, and at the end, we can just defer and we can go length plus equal to 4 uh, 8 plus sticks length. And here we can, so the first thing we are going to write is, what is it? Sticks with that capitalization. And this is going to be the form length. And here we need to uh, through do unimplemented work out form size. Yeah, because we can't. The first right sticks length. Which like I don't know. I I just don't know how you can work out where you are in a file. Well, like there's the ftil, not in this package. F till. It's just interesting that and a file is like a structure type thing, which os dot handle OEN OS no os dot handle. What is this? This is so uint pointer, so it's a pointer to something. So I think it is fine to use in a thing. Oh, we can do right X. We don't need to do weird seeks. Um, um, I just want to be able to. This returns where we were from. I don't really want to know what that is. Um, yeah, so maybe that's how we get tell. If we go os dot seek fd 0 and cur. Um, so if we seek to the current thing, this should we should really do something like that, just in case we can't seek. And here we should get right. So this is going to be the sticks offset, I guess, but also an error, and that can be that. And here we will do a defer such as that, except our defer we will just do Getzel phone right, and we'll do it to FD. We'll first seek to sticks offset. And then we'll write the sticks length, and we'll pass it form length. Don't need any of that, but this is going to be end air. Do something like that. And here we probably just want to go to the end and do something like that. I think that is kind of what I want to do. And yeah, from there, need to write some things. But yeah, that's kind of what I want to do. It's good to know that I can get the offset from the current seek. So that should well, yeah, I'll keep this in. I mean, something like that. And the important thing is we're writing to stacks length rather than the length that we pass, but we will add that to the form length of the surrounding form. Um, but yeah, this looks pretty good. My eye is getting quite wonky, so I think I'm gonna leave it there for today because it's quite hard to focus, and that's just gonna slow me down and not gonna be entertaining for you. But don't worry about me. It is a known side effect of one of the meds I'm on, and I'm happy with it. It'll go away eventually. But yeah, thanks for watching this far if you have, and if you enjoy it, let me know. And hopefully, sometime soon we'll get sailing properly finished. I did think it would have been a bit quicker, but it is what it is. But yeah, thanks for watching, and I'll see you another time.